Welcome to qnawire.
Okay, so for the pendulum, we have the energy equation like this, which is initial potential energy plus the initial kinetic energy should be equal to final potential energy plus the final kinetic energy. So since the initial kinetic energy of a pendulum should be equal to 0, same for the final potential energy of the pendulum. So therefore, we have UGI is equal to KF. So this is the energy bar chart I drew for this question. So the initial potential energy should be equal to the final kinetic energy. So the initial states I pick for the pendulum is at a maximum angular displacement, okay? And the final state should be at the equilibrium position, okay? Because at the equilibrium position, the velocity is the maximum, okay? Because at a point, all that potential energy was converted to kinetic energy, which is the final kinetic energy at that point. So the assumption I made is that there's no energy loss to the surroundings, okay? So because there's no energy loss, so all the potential energy can be converted to the kinetic energy. And for the beach ball, this is the equation of the energy for the beach ball. So the initial kinetic energy and the final potential energy should be equal to 0. So therefore, we have initial potential energy is equal to final kinetic energy. And this is the energy bar chart I drew for the beach ball. So the initial state I pick is when the beach ball is under the surface of water. Okay, so at that point, the potential energy is at a maximum, and the final state should be the equilibrium position. And at the equilibrium position, the velocity is at a maximum. Okay, so therefore the kinetic energy is at a maximum. So the assumption I made is also there's no energy loss. So that's why all the potential energy can be converted into the kinetic energy. And for medicine ball, this is the energy equation for the medicine ball, which is initial potential energy plus the initial kinetic energy is equal to final potential energy plus the final kinetic energy plus the energy loss, or in other words, heat loss. Because if you take a look at the motion of medicine ball, the height after each rebound is getting lower and lower. So eventually the medicine ball will drop to the ground without rebounding. Okay. So we also know that the initial kinetic energy and the final potential energy should be equal to 0 because the initial state and final state I pick. Okay. And since there's heat loss, that means the initial potential energy should be greater than the final kinetic energy. So this is the energy bar chart I drew for this question. So the initial state I pick is at the highest point. So at the highest point, the medicine ball had the maximum potential energy. And final state I pick is on the ground. So on the ground, there's no potential energy. So the potential energy becomes 0. And all those potential energy, not all those, most of the potential energy was converted to the final kinetic energy here. Okay. Why in this case there's no so in this case not all the potential energy was converted to the kinetic energy is because there's heat loss here, there's energy loss. So my assumption made is there's energy loss here. Okay. And that's why the ball was bouncing on the ground until it stayed on the ground. Okay, as you can tell, the height after each rebounding is getting lower and lower. Okay, because there's energy loss every time when the ball get in contact with the ground. And these are the answers for this question.